Okay, so let's play like a little game before we start. Could you just post your country's flag in the chat? Let's just know where you guys are coming in from. Just post your country's flag in the chat. Let's see. You guys post your country's flag in the chat. Let me see. Let me see my countries. Do they have a? Uh, okay, I see from Ethiopia, Nigeria, Senegal, Ethiopia. Oh, Nigeria. Hi, Lawson, Kenya. Okay. Ethiopia again. Okay. I'm loving this. Kenya. Okay. Nice. Drop your country's flag in the chat, please. Really nice. Three people. But I'm starting about a minute's time. Can you guys hear me? Erica, can you hear me?
So I think your voice is breaking a bit. Could you talk again so we try that out again?
Can you hear me? Can you hear me properly?
Yeah, I can hear you. But it seems it's cracking, I think.
Okay. Sorry, give me a sec. Give me a minute. Is it better now?
Yeah, it is.
Okay. Okay. So during the course of the presentation, I'll probably be sharing my screen. So do let me know if you lose me at any point in time. Okay.
Sure, I will. Sure, I will.
Okay. So I'm going to start sharing my screen. So good evening, everyone. You're welcome to today's session with NSKito AI. Today we're going to be reviewing a paper, and I'm going to be your speaker. So today's paper would be titled "Retrieval Augmented Generation for Large Language Models: A Survey." So it's a survey paper. We sent out emails earlier today, giving links to the paper. Um, You can also check the Discord channel because we've also put the link there, and also the WhatsApp group, so you could all have access to the paper. So after the talk, in case you want to read further. So at this point, I'm going to start sharing my screen. Yeah, can you confirm that you can see my screen?
Yeah, screen is sharing.
Okay, solid. So hi everyone. My name is Ifan Okala. I am the founder of NSKito AI. I'm also an independent AI researcher, and then I'm also an NVIDIA DLI instructor. So I'm going to just tell you a bit about myself, a bit about NSKito AI. I think it's a lot of people have asked who we are, how did the name come about. So I'll just spend a very short time talking about that. When I was in university, I schooled at the University of Nigeria in Nsukka, and I had like a few of my friends that wanted to go into AI, but we never really knew how to like start. And so a friend of mine just came and was like, "Oh, hi, fine. Should we start a community?" And I thought about it. I was like, "Yeah, and that was the goal. We just wanted to like maybe have like a community for ourselves where we could all feel comfortable." And that was how NSQ AI started. And By November this year, we would have been in existence for 4 years, and we've grown. This boot camp is it just speaks volumes about our existence. We're just here to help people that want to get into AI, make things easier. That bridge from AI to whatever level you are at, that was what led us here. Um, and so I'll just say something about the name because I've had a few people ask me about the name. So I schooled in Osaka, and when I went to Osaka, I love the place. Like I grew up in Lagos where there are no trees, just cars and noise. And went to Suga, there are lots of trees. And um, I um, I told myself that I wanted to do something to make people remember Nosogba. So there's a typical thing we say in Nosogba. So we call it NSK. So the reason why I named the NSK the area was so that when people heard the word NSK, they would think it means Nsukka. And so it makes you go and read about Nsukka so you know about the place. But NSK does not mean Nsukka. It's just to make you ask what does NSK mean, and then you assume that it's in Suka, and you go and check out Suka because I never knew about Suka till I went there, and I said okay fine because the space gave birth NSK to AI. I'm going to make sure people always remember it. So that's everything. So if you want to scan the barcode to get to know me more, we can link up on LinkedIn, and the link to my profile is also here. So that's about me. Oh yeah, I also have a very I'm very interested in how AI and health interrelate. So my research interest is primarily on AI and mental health. Um, I also have like an interest in building world models for robots. That's a place I'm slightly trying to navigate to. So, if you have any research, if our research interests align, you could always hit me up and we could talk further. Yeah. So let's move on to the paper. So today's paper is going to be, as I said, retrieval augmented generation for large language models. It's a survey. I think this paper is very interesting because it takes us from naive RAG to advanced RAG to modular RAG. It really does do justice to everything involved in RAG, from what was, what used to be, and what is, and why this is the new industry standard, and also talks about the new dynamics of where the world is going to, and how RAG is really, really impacting, and whether RAG will be, the paper asks some very critical questions. Will RAG still be useful with these new changes that are coming up? And I really hope it's just going to open up your mind to really understand what RAG is all about and how powerful it is. Um, can you confirm that you can hear me? Ebuka, can
Yeah,
you
yeah,
confirm that you can hear me?
yeah, yeah. You're good.
Okay, okay,
If I
okay.
can, if you
As
can't
we
hear
all
me,
know,
I'll let you know.
okay, cool, cool, cool. As we all know, RAG stands for Retrieval Augmented Generation, and yeah. So let's go down. Um, there, RAG played a very, so the diagram you can see now, basically is trying to show you three main areas. The naive RAG we all know is basically RAG that is involved in inference. By inference, what I mean is, when so the user oh, should I do the diagram? Okay, let me use this diagram. Yeah, this is perfect. So a user makes a query, and for that query, there's a vector database, as you can see here, and it has like all the information, the external information, aside the information that the LLM was trained upon. And so the LLM has to now, okay, the user has given this query. Let me go to my database. Let me go and retrieve that information from my vector database. Then this retrieved information is now added to the context window for the LLM. As you can see in this particular example, the user asked a question about evaluating OpenAI CEO, and I'm asking about the issue with the board, and also asking a resemblance with Game of Thrones. Okay, that's the query. Now, um, then this query, so that there's now a retrieval that now goes to the index, now check, okay, what exists on this kind of query. Now, so you get the information, you can see information about Sam Altman, yeah, different chunks of information from the vector database. Now, all of that information is now added to the query from the user. Now, the LLM now uses this information to generate an answer. Why I'm saying this is because back to the original image here, it shows that the LLM, so RAG was primarily it was used in the inference level. But actually, people cannot. Now, one thing you need to understand that people are using RAG for pre training, for fine tuning. So it's no longer just at the inference level anymore. People are using it to pre train their models, they're using it to fine tune their models. I'm going to go deeper into all of this as we go down, but I just wanted to give you that understanding. If you have any questions, please put them in the chat. I'm sure Sai is on the call, so he's going to help to answer some questions, and I can also take some questions at the end of the talk. Um, yeah, so I've already given you. So we're going to go into naive RAG, as I already said. Um, you can break it down into three areas. So indexing, which is getting your data. It could be PDF, HTML, Word, whatever format for it to be utilized. Pardon me. Oh gosh, sorry. Okay, you guys can still see me?
Sure, sure, sure. Yeah, we can see you.
Yeah, NEPA just happened.
That's fine. Yeah, go
Okay,
ahead.
cool. So since you guys can still see me, cool, no problem. I just want to make sure you can see me. So you have the indexing. So where the information you've gotten is like broken down into smaller digestible chunks, and they're now stored. The index. Okay, this is one, this is two. Is all stored there. The next thing is the retrieval. Remember in the original diagram, which is this guy. So the information has already been indexed. So whatever format it is, it could be HTML, PDF, whatever format it is. Now it's the retrieval that happens next. So when a user gives a query, now that vector database is there's a retrieval that goes, okay, what is important based on indexing? So okay, what do I need based on the user's query? What do I need from this vector database that is important for me? Then after the retrieval, there is the generation. So where um, the retrieval plus the user's query is used to give an output. This is basic RAG that we all know. This is naive RAG. And this is going to be one of the projects that we're going to work on. Now, this method of RAG has its challenges. So, as I mentioned, I'm going to take you from, you could call it baby RAG, naive RAG to advanced RAG to modular RAG. You're literally seeing the progressions of how we started and how we've grown. Something I wanted to mention again was, ChatGPT was very, very instrumental in the adoption of RAG. Because around the time when there was a boom, ChatGPT came out, lots of people started using RAG because of how effective it was. Because it gave a lot more context to certain user prompts. Now, there are certain difficulties. One, namely that there is a possibility that in retrieval, the LLM can retrieve the wrong information, which really doesn't help in the response. Um, there is also the possibility of hallucination, as I was kind of linked to the first thing, because you're retrieving information that's not useful to the model, and in the end, you now give output that is way, way off. So these issues are prevalent in the naive RAG. Now, moving on to the advanced RAG. The advanced RAG literally was an improvement on the. Okay, yeah, let me use this guy. Should I use? Okay, let me use the diagram. I think that's going to give you guys a better understanding. So the advanced RAG now went a higher step. So remember the problems for the naive RAG. So how was I getting retrieving from my vector database? There were issues. Now after I get it and I'm feeding it LLM, there were still some loopholes, and advanced RAG tried to try and improve on these ones, so on these loopholes. One of them being, so can you confirm that you can see the screen properly? Because I zoomed in. I can zoom in more if you need me to do that. Hello.
Yeah, yeah, we can
Okay,
see the screen properly. Yeah, yeah,
okay,
yeah.
solid. So one of them being pre-retrieval. So before
Um,
so
if
before
I hi,
yeah, Yes,
So
yes.
Sai is asking, can you use your mouse to highlight what you're talking about?
Okay. So can you see? Can you see this? Let me see. Okay, let me
Yeah,
use. I think
yeah.
Zoom. I don't want to start writing on the board. Do I? Can I just use my mouse? Is that good?
Uh, yeah, you can use your mouse, but I think
Okay.
if you could use the chalk from Zoom, I think that would be better. But yeah, you can use your
Okay.
mouse. I think everybody's okay
Okay.
with
But
that.
cool. No
Yeah.
problem. Let me do that. So you guys can see. Okay. Let's see. Okay, yeah, I can't use it here. So, but nonetheless, so the pre-retrieval. Now, one of the things that were done was that there are times when the user's query, for instance, you need to ask yourself, what kind of query is this? You know, um, do I need to expand on the user's query? Because before you retrieve, maybe the user's prompt was not very sufficient. In order for the LLM to retrieve the kind right information it needs, maybe you could give it more options. So like you expand on the user's query. That helps. So this area, please, for those of you who need me to show you. So there's that expansion of the user's query. One that's just helping so that in the retrieval process there is um higher accuracy, because if the query is better, there's a better retrieval. So that's one of the things. Another possibility was rewriting of queries. So if the user's query was so bad, it's possible to rewrite the LLM, rewrite it, or still, catching the key things, but writing it so that it gets the best um, outputs. And so then moving on to retrieval. Even after retrieval, there are techniques that were implemented to even get better responses. This is so in the context window with the LLM. One being, if there are many things that were retrieved from the vector database, there is a possibility to re-rank. So if I retrieve maybe 10 chunks based on the user's query, it's ranked from the highest relevance, and it's possible that maybe okay, it's only the top five, because if you're taking all 20 and just feeding it into the LLM, there is a possibility of too much information that is not necessary that now leads to giving a very invalid outputs or erroneous outputs. So that ranking was also very useful. Another thing that was done is summarization. So again, that's these are techniques that have been implemented. So re-ranking, summarization, these are techniques that were implemented to get better results with RAG. But again, as I said, this was not the best. There were still loopholes. And this is now what leads us to modular RAG. I found this very, very interesting because for those of you who have any experience with using servers or maybe DevOps, I think you'll be able to relate to this more. Um, for instance, if you have like a web application, there's a front end, there's okay, yeah, an e-commerce website, there's a front end, the user has to buy things, the user has to pay, and the user has a cart. All these things are functions, authentication. So what is being adopted is a technique called containerization. So when you have such a large application, you can see that all these functions are kind of dependent on each other. So we have the user's information when the user buys something, when the user pays. If one thing goes wrong or the site goes down, everything goes down. And so there was a flaw in the system. And so that's where containerization came, where you're able to put all these tiny functions. So the front end can be in one container, um, the payment can be in another container, the cart can be in another container, and they're all acting together but independently. And if one goes down, it doesn't shut down the whole system. So basically, everything from naive RAG to advanced RAG is what was now used in modular RAG. So let me explain. As I mentioned, there are many things that need to be done in RAG. When a user gives a query, there has to be research. Where do I get information for this? Do I go to the web? Do I go to this database? Do I go to this place? Search. What kind of retrieval do I need? You know, where is this information going to be stored? Routing. Do I need to rewrite what the user gave to me? Rewriting. Do I need to re-rank what I have retrieved? Re-ranking. Um, is there a place where I need to go and check my memory for all the things that the user has, all the past conversations I've had with the user, where I've gotten information from, because that's all going to be important. And that's the beautiful thing about modules. So that's why it's called modular RAG, because the these tiny functions are all separated, all to now make up this modular RAG where, this is what we need to go step by step to get the best results. Now, patterns, where patterns comes in is, now there are many things that can be done. You can search from here, you can route, you can retrieve, you can rewrite, you can re-rank, you can read. So this is here. But every task is unique. There are actually certain tasks that you don't even need to retrieve at all. Maybe all you just need to do is let the LLM give you an output. And there are tasks where you just need to retrieve and read. That is it. But there are times where you need to search, rewrite, re-rank, check your memory, add it all together, add all the output, all the retrieved chunks, add it to one to feed it into context window for the LLM. So patterns basically helps you to decide on, okay, what do I do? How do I organize this? Do I need to go retrieve, read, retrieve, read? Do I need to go search, route, retrieve, rewrite, re-rank? Go back again, retrieve, read. That's what patterns is all about. So more of like, how do you arrange the flow of it? So these are the three. So again, I'm going to go in depth into modular RAG. So each of the independent functions. So we're going to go into depth about all of them. But this is very, very interesting, because for me, when I was preparing for this was the first time I come across this. I kind of had a relatively good understanding of advanced RAG, but I never knew about modular RAG. So I hope you're learning something new, because I think something that's important is, of course, along the line of this bootcamp, I hope you're starting to see how things are heating up in complexity. I know at the beginning I saw lots of people complaining that we're not writing code. We're not writing code. So you can see like it's building slowly. It's like you started as like a baby, and then you're getting more and more exposed into more complex things, the potentials of RAG, the possibilities, and then we're going to start building, because the bootcamp is not just for the hackathon, the capstone project, but it's for beyond. So you have like a very good understanding of RAG and how it's being used. Um, yeah, so I've kind of covered all these areas. So let's move on. So now we're going to go to retrieval. So this is where I'm at. Um, I wish I had like a marker, but yeah, this is where I'm at. I'm at retrieval. So we're going to like go over the key concepts that are important that you need to consider. Let me see. Yeah. So one of them being retrieval. Now, the retrieval source, as I mentioned, is important. Um, where you retrieve your data from is important. So, there are different types of data structures. You have unstructured data and you have structured data. So unstructured data are mostly text, the text you usually see every. These are unstructured data. And there's semi-structured data, data that combines, tables and text, such as PDF. Something that's important about unstructured data is that usually when rack systems have to deal with unstructured data, it really doesn't do so well, because it's really difficult, because when you're trying to split the text it's easy. When you're now dealing with the tables, it becomes a problem. So I don't know if you've noticed that when you feed your PDFs to any of the popular large language models you see, if the PDF has like lots of tables, if it doesn't actually catch, when it doesn't catch that portion of the table, it struggles. It usually will catch the text parts. Another hint to something we're going to talk about, it usually catches what's at the beginning and what's at the base. I had this problem recently. I fed in I think I sent in a PDF, and I noticed it just took like the top and the bottom, and I was like, what happened to the middle? So it's one of the loopholes, but especially when your context, when whatever you put into it is too much, it's going to really struggle for what's in the middle. Now, the structured data, which is very interesting, I need to I need to dramatize this. Let's see. Okay, so let me see. Sorry, let me just stop sharing. So let me find a plain sheet for you guys. Give me a second.
So yeah, while he's working on that, let us know if you're following, if you're able to, if you're also following the paper, the link to the paper. Let us know if you are understanding and if you're following the whole talk so far in the chat while he's working on setting up the chalk. Someone is asking why
Okay,
the yeah.
yeah,
Yeah, you can. So someone is so you asked when can we ask questions? You can start dropping your questions in the chat
in
boards.
the chat. Yeah, yeah.
Yeah, start dropping your questions in the chat. We'll attend to all of them.
Okay, so basically, I wasn't able to get figure that out, but I think I can pass on the concept properly here. So in knowledge graphs, so knowledge graphs are basically like data ways of representing your data with graphs, and there are two terms that are very important. One, nodes and entities. So nodes are basically so you can see person, name Daniel, that is a node. Order ID, that is a node. Product name Salmon, that is a node. Entities are basically, you could say, they're basically the things that connect two nodes together. So Daniel is linked to order ID because that is his order. This is important. So why I'm saying this is important is I'm going to talk about knowledge graphs a lot. Um, and yeah, but hey, yeah. So this is even perfect. So you can see the node is Daniel and another node is order. The entity that connects the two of them is place order. So because Daniel placed an order, this is how a way of representing information that helps the LLMs to have a better understanding. You know, there's certain nuances that you cannot understand because you don't. When the data is stored in a certain format, there's certain things you don't see. How, for instance, if you have a sentence and it talks about this boy, what example? Okay, this boy is the CEO and he's suffering from tuberculosis and um, he grew up in an environment that was very toxic. That's a very good explanation. There is a very good relationship to what he's suffering from to the environment he grew in. If the way you can pass that to an LM, the possibilities that you won't really get the nuances that what he's suffering from is directly related to what to his illness and his environment basically. So knowledge graphs are like a form of structured data, but the disadvantage, if I call it disadvantage, is it's not very easy to build. It's difficult to build, it's difficult to validate, and it's also difficult to maintain. So these are why I'm saying this is so that you know the different sources of data that's used for RAG systems. Another one is LLM generated content. So there are issues in the sense that the for not now this is not in production you most likely will not use this, but there are many risks that okay what you've retrieved from your data source might give you information that is not necessary. It might give you information that is not actually beneficial to the actual context of the user's query. So there are research has shown that when you use LLM generated content, you know, instead of using retrieving from an external source to add context to the user's query. So that's what we're doing here. You get a better response. But I said this is not really something that's used in um, production. It's just something that I want you to know that it happens. People do use their certain systems. I don't know of any system that's actually used in production, but you obviously have better responses because the thing they're trying to increase is precision and recall. So precision is how accurate your responses are. Recall is how much of the useful chunks. So were if they're like 100 bags, there are 100 balls in a bag, and 20 of them are good. How many of the 20 did I get? That's basically what recall is. So if I can get 20 out of 20, I have 100% recall. If I get 10 out of 20, I get that's 5%. Yeah, that's 5% recall. So you just have higher precision and recall if you use LLM generated content instead of retrieving from an external source. Another factor which I think is important is retrieval granularity. So granularity basically is talking about there are basically two types: coarse grained units and fine grained units. So how large? So you remember I mentioned I was talking about chunks, and I'm going to touch on this later. Um, if you take from whatever data source you're using, if the chunk is too large, there is a possibility that your LLM might that's too much information that it needs. If it's too small, it's accurate, but you might miss out on the context. You know, there's certain nuances that you miss out. So fine grain is obviously like taking smaller chunks, but it's more specific to whatever the task is. But then you run the risk of not getting the full context. You know, there might be some more information if you took more, but coarse grain, you're getting way more. You most likely will get more than you need. So there has to be, you know, that balance of do you want how much do you want? Do you want like a large chunk, a smaller chunk? Again, another thing about the fine grain chunk is computation because you're taking small, you have to take lots of small bits. So there has to be this balance. Um, in your project, you're going to do a lot of, you know, you're going to decide on your chunk size. Do you want a chunk size of 50? We're going to even talk about overlapping chunks. That I'll touch on that moving forward. 6:30, so I need to pick up the pace. Um, yes. So remember, perfect. So I'm going to even talk about it here. So remember, I talked about indexing. So how these documents are transformed into embeddings. If I remember yesterday, I think the speaker yesterday talked about it. So I'm going to run through it again. So you know when your when the user gives a query, it's sent as text. Now there is a need for the LLM to kind of store this user query. Oh no, let's not even go there. Let's go to the retrieved information. So if you have a vector database, they're stored as vectors. Now, what are vectors? Basically, like numerical representations of data. Why it's stored like that? It's more efficient and it's also easier to find similar. So there's something called cosine similarity. So if I have two vectors, um, that are similar. They're kind of brought together because they're basically within similar contexts. Why this is important is because when you're trying to retrieve information, it's a lot easier if I know that, oh, this guy is here and there's somebody right beside him. So I don't need to go and start checking the entire. So look at it like a box, you know. You've arranged your books. I'm sorry I don't have images to represent these things, but if you just pay attention, I'm sure you're going to get the concept. So you've arranged your books in your house, and you have chemistry books to one side, you have physics books to another side, you have English books to another side, you have math books to another side, you have geography books together. So they're all like together, they're clustered together. So that's the beauty of storing things as vectors. Because when you're now looking for, when the user gives you a query that's okay for math, I don't need to start looking through all my books. I just need to know go for where I stored math books. It's a lot easier for me to find the particular thing I'm looking for. You know, so the thing we're trying to do is how are we going to make this faster? How can we retrieve information accurately and faster? There are lots of techniques that I think will wow your mind on the things that people have integrated to make retrieval more accurate and way more fun. So as I mentioned, the chunking strategy, they're usually um, chunks are, the documents are split into fixed number of tokens. So basically, maybe 100, 256, 512, different sizes. Well, because this is like the standard. Now, as I mentioned, larger chunks can capture more context, but they generate more noise. So increase that now gives you longer processing time and higher cost. Another thing that you're going to come across metadata attachments. So lots of things that are being done when you have a data source, or let's say a chunk. So a chunk, you've gotten data from wherever. Maybe it could be PDF, it could be text, and you've broken down into like tiny, tiny chunks. Every chunk has a bit of information. There's something about that chunk, and so there's something called metadata where you store information about that chunk that will be relevant when you're searching. It's almost like I'll go back to the representation about the books. So within my physics category, there are books on space. So there's a smaller subset of books on space, and there are books that talks now. We know they talk about space. Then there are those that talk about the planets. Maybe there are even more that talk about the first four planets. These metadata attachments just help to buttress your chunks so that to increase the speed of retrieval. This is very, very important because it's something that um, you're going to see across the capstone projects. That's why these metadata attachments are there. It's something that's very, very important um, that you need to understand. There's even another technique that is added are summaries. So summaries are attached to now for instance some of the metadata you can get on page number, file name, the author, the category timestamp. Summaries also. This is something that I found very insightful. So summaries about what that chunk is about. The whole aim, understand again, is still the same principle. How can we make sure that whatever we're retrieving is what we need, not more than what we need, exactly what we need to get us the perfect answer that the user wants? That's literally all that's happening. Every advancement has been towards the same end goal. How can we get exactly what the user wants with minimal time and minimal computation? This is the key thing. Okay. Um, Another thing I wanted to mention was indexing. So, something that's important is when the in the vector database, it's possible that there's a technique called hierarchical data structure where the files are arranged in a parent-child um, structure. So instead of when a user makes a query and there is a retrieval that has to be done, the first step is obviously go to the parents to now check, okay, I know a bit about you, I know your metadata. Do you have what I need? I know that it's your line. If you don't have what I need, then I'll now start going out to your kids. Again, it's just little techniques that will help you to um, get better results. Another one is knowledge graph index, which is very similar to what I told you about knowledge graph, how you have nodes and entities. So just combining these two, just techniques that help you to retrieve the best form of information, or yeah, relevant information. Um, Now going to query optimization. If you remember earlier when I talked about there's certain techniques that have been introduced, I think in advanced RAG that were integrated to help improve, to help get better results. One of them being query expansion. So expanding a single query into multiple queries so that you have multiple options. And then another thing you can do is you expand them with an LLM, and then you actually now retrieve. So you get multiple chunks. So you do a retrieval on this query, you do a retrieval on this query, you do a retrieval on this query. All these techniques are so that you can get the very best answer. And there is the possibility of now combining, fusing all the entire retrieved information to one, so that then you now feed that to the context of the LLM. So remember I mentioned that the LLM has the user's query and the context, which is usually what is retrieved. Let's see. Okay, so let's move on to, yes, query transformation. Another thing that could be done is the original queries are not always optimal for LLM retrieval. So it's also a technique that has been utilized and seen to um, bring useful results. Usually, smaller large language models are used. So these smaller large models are used for to write queries. Um, I also talked about query routing. So remember, this is very, very interesting. So everything we've talked about, do you remember in the modular RAG? I think it's important if I go so you guys can see that everything we're talking about. Sorry, I need to go up and so you can see this because it all comes together. So you can see we've talked about rerouting, we've talked about rewriting, we've talked about re-ranking, we've talked about fusion. So you can see how these individual techniques are useful to give that final result of what is the best thing, what are the best steps taken to give you the best results. Every query has it's unique in its own way. Certain things don't need certain things. If you get what I'm saying. So if, for instance, the user's query is good enough, there's no need to rewrite. But again, it depends on the query, and that's what guides us. So I want you to. So we've. I guess we went to the top. Now we're starting from the bottom, but I had to take you back to comes to top so that everything comes together. So it's basically like a top to bottom approach of learning. Yeah. I don't know. At this point, I think I want to maybe take a little pause and know like how you guys are doing. I'm gonna stop sharing for just a bit. I haven't really. So yeah, how's it going? How's it going, everyone? I like to just hear because I know I've been talking for a very long time. Ibuka, can you tell me how is it really insightful? Okay, hi, thanks, Sai.
Yeah,
That's
yeah,
nice.
yeah. Yeah, you've been
Okay,
doing
type
great.
type. Okay, thank you. But I hope you guys are following. Because um, it's actually very very insightful. The many things. Thank you so much, Fidel. It's really nice that you guys are following, and the most important thing for me is just exposing your mind to RAG and the different techniques that are being implemented. Okay, thank you guys. The claps are really really encouraging. So I'm going to go back to sharing my slide. I just wanted to know that you guys are following. I have about 15 minutes, so I'm going to try and um finish up. Okay, let's go back down. Okay. Um, I think I've touched on, yeah, query writing. How do we do this? Okay, yeah. So now query routing there, again, as I mentioned, routing to know which RAG pipeline is suitable for the system. There are two main techniques that are
Fine.
utilized. Meta.
That's
Hello.
fine.
Yes.
Yeah. Could you briefly make Sai a host?
Okay. Um.
Yeah,
Okay.
thank you.
Okay. Um, yep. Are we good?
Yeah, yeah, yeah. Thank you.
Okay. Lovely. So query routing is basically there are two main techniques. One, metadata routing of slash filter or semantic router. So it basically involves extracting the keywords from the query, and um, so these keywords are now matched with the metadata within the chunks to narrow down the search scope. So remember I told you the metadata is information, just extra information for the chunks. So it makes a lot of sense if when I get the user's query, I actually like extract keywords from it. So it helps me to know, okay, this is these are the main things I need, and I can compare it with what I have within the chunks to narrow down what I'm searching for. Remember, the key thing is these techniques are just going to what is the best way for me to get the best information and the relevant information I need to give maximum outputs to the user. Now, another technique is the semantic router, which basically goes to semantics of the semantic information of the query. So looking at the actual meaning of the query from the user. Um, but again, maybe a hybrid approach can be employed, and both combining semantic and metadata actually um, gives you maybe the best results. Debatable, but yes, so that's something you need to note. Um, so let's move on. I think I'm running out of time, so there's something I want to touch on. Yes, generation. So, as we know, okay, we've touched on the query retrieval, generation. There's certain things that are very important. Um, Remember, I mentioned to you that there's something called re-ranking. So, in your, for instance, in your vector database, for instance, you have your chunks, and there is a need to we rank based on what is what's the user's query, what is useful, because you know that thing of there's a possibility that there's a lot of information that is not useful to the user's query or the particular task that the user wants from the LLM. So that ranking is very it reorders all the chunks to highlight the most important results first. So there's no need to now go and start looking through everything. Remember I mentioned to you that there is a tendency for LLMs to they call it get lost in the middle when you give it very very long context. So it just focuses on the beginning and the end. So it just forgets the middle. So that ranking is very important. So the most essential things are what place at the top. So priority is given to that so that again just to maximize the result that is gotten. Okay. Another thing that I think people um, will find very insightful is context selection or compression, where you know actually small language models are used to remove unimportant tokens, and then these tokens, so tokens are basically the user's queries, but numerical representations of the user's not numerical representations, but formats that is useful for the LLM to kind of understand. So now these tokens that the user feeds to the LLM within the context window, there may be information that's not necessary that could be seen as noise. And so there is like an LLM, a smaller large language model, a smaller model that actually helps to remove unimportant tokens, transforming it into a form that humans might not be able to read because it doesn't make sense. It's all, scattered. But it also shows we've also seen that this compression actually leads to better results. So these are techniques that have been implemented that give you very useful results. Um, yes, this. I'm going to use this diagrams to explain this. So we're talking about augmentation processing, right? So there are three main processes. Um, Basically, you know that the basic fundamental is that the user gives a query, you want to retrieve, you want to generate a response that you feed to the user. Now, there are three techniques that for retrieval. Each have their strengths, each have each have their strengths, and I think you get to see how they have like gone from this is the first version, version 2, version 3. So the iterative process, let me not waste time. So you can see that the user there's a query, a retrieval is done, and a generation is done. Then there is a judge in the loop, as you can see from here. There's a judge in the loops that now says, okay, let me look at the response, the outputs, and now put that output as the context plus the user's query. Because there is a certain threshold that has been internally set, or a maximum number of iterations that could be taken to get the best possible result for the user. So again, I'll repeat. So query, retrieval is done, generation is done. So the output is now used as context with the query. So to make sure then so there's a certain threshold, a minimum point where okay, it's good enough. Is it getting to this score that I wanted to before I give it to the user. There is another technique called the recursive retrieval. This is a little bit different. Um, there is a query, there is a retrieval, and there is a generation. Now, this generation is now used to basically maybe find out, do I need to transform my query or reduce it? So in the other one, nothing in iterative, nothing was being done to the query. The query was not being touched at all. The output was added as context to the query to give a response. But in this one, the results are used to either augment, in transform or decompose the query to get that maximum threshold, or no, that threshold, that point of, okay, this is the best result. Then the adaptive retrieval, which I found very, very interesting. Oh my gosh, I have 7 minutes. Um, so the it goes through the same process. That process of constantly, the LLM actually decides on its own what it needs to retrieve. So I have a query and I generate. The LLM now looks at the response and is like, I need this information. So from that response, it goes back. And then that same loop of changing the query to fit um, the yeah, changing the query to make sure, okay, do I need to reduce the query or not? It goes into that loop. But the LLM is the one that decides whether or not it needs to retrieve information, what it needs to retrieve, when it needs to retrieve. That is just the thing about the adaptive retrieval. So there's the iterative, recursive, and adaptive retrieval. Um, yeah, so that I've explained that with the okay. So task and evaluations. I decided to skip this. So you can read the paper on your own and review. So I'll just highlight on a few things because we've kind of gotten to the end of this talk. There are future things that we need to understand is RAG. Do we need RAG? We're in the era where we have context windows. I think Google Gemini's context window is about 1 million tokens. Llama in their paper talked about there is the goal is to get to an infinite context window. The reason why you could say RAG came into existence was basically because you couldn't feed everything to the large language model because it has a limit. The context window is limited. So you want to be able to give it what it actually needs. So is RAG still relevant? When we get to that point where the context window gets so massive, is it relevant? These are areas for discussion. And something I wanted to mention, RAG is not just only for retrieval. RAG is also keeping track. Most of you may use Perplexity. How do you think Perplexity keeps tracks on where you got this from? How do you think Perplexity works? It retrieves information from certain places and keeps track of them. So this is something that um, I food for thoughts basically for you to think about and how how important RAG is. There are also scaling laws with RAG. You know, there's this narrative that with larger models you have um, better results. You have larger models do better. With RAG, um, is that the same narrative? You know, these are areas of food for thought. Basically, I wanted to leave this here so that you could all think about it. This paper basically talks about everything we're talking about. You can go through it. Let's see. Yeah, I think at this point, I think we've. I can't believe I was able to keep this within an hour. So I'm gonna stop sharing my. Okay, yes. So I wanted to say this. Um, it's been fascinating for me reading this paper and preparing for this talk. I hope you've been able to. I hope you're as excited as I am about RAG. I never knew that RAG was this important. RAG was this fun, and RAG had this level of importance in our ecosystem. I'm excited to see what happens. Moving forward. Different ways that people use RAG. It's exciting to know that in even Perplexity they're using RAG. Have you noticed that how GPT kind of has your information, like stores your information in a certain database? How does it now get that information to add? when you give it a query, to the context window, and it gives you a response, understanding who you are and understanding your query. So you can see that's a very real life representation of RAG, understanding how modular RAG now even works. So when you're actually in deployment in production, what kind of RAG systems are you building? Are you building a naive RAG, an advanced RAG, and a modular RAG project? So I'll end with this. I came up with a very simple poem. People might find it cliche, but I'm going to say it irrespective. Roses are red, violets are blue. What would the AI world be without RAG? Thank you very much. I hope you guys like my poem. Everybody is
Yeah,
smiling.
yeah,
Thank you
yeah.
so much. Okay. Now I can see you smiling too. Thank you.
Yeah,
I love the paper. I love the paper. Thank you guys.
yeah.
That was
Thank you.
Thank you, Francis. Um
Yeah.
so that's
So
now
yeah,
time for
if
questions.
there are anyone, yeah, it's time for questions. If you have any questions, can you please
Yeah.
drop them in the chat? But um, want
Sai,
to
would you
know
would you like
if you,
to Sai, would you like to engage questions?
Yeah, let's do the questions.
Yeah. So you can put your
Uh,
question in the chat, please.
yeah, the first question I saw that is about like, is knowledge graph stored in a vector database, and if not, what's the difference between both? Ibuka answered the questions correctly. I'm just going to repeat it. So knowledge graph and it can be stored in vector database, but it will be like very inefficient. Uh, but so knowledge graph is generally stored in graph database. That's like separate categories of database called graph database, and they facilitate additional functionalities like neighboring node retrieval, multi-hop retrieval. Let's say uh, Ifani is founder of NSK.ai, right? And Sai is advisor. So it's like multi-hop. Like we both are, Ifani and Sai is connected by NSK. So it's like one hop reasoning. So graph database has additional functionalities to help you do that. Um, Yep. And the next question from computing and informatics, uh, cool name, is uh, how do current retrieval techniques like BM25 and DPR differ? DPR is like dense paragraph retrieval, differ in capturing semantic relevance, and what implications does this have for RAG accuracy? So BM25, to give like a overview, it's using word presence. Like it just looks at, okay, your query has these many these words, and your passage have these many words, and it computes how many words are similar, and it computes similarity score based on that. Dense passage retrieval uses an embedding model to find similarity between the two sentences. BM25 is extremely fast, and it works really reasonably well in most occasions. And DPR is a bit slower, and it takes more memory to store them. So, but theoretically, it should give you highly relevant similarity scores between two similar ones. And there are cases where BM25 might not work well, especially when I say soy does not work at Amazon, right? And if the question is, does soy work at Amazon, right? Like that's a bad example, but anyway, the BM25 does not really work well when there is like negations, or when you have similar words like beautiful and pretty. Like it won't know the difference. Dense passage retrieval knows these things. uh, in general, like if Annie mentioned, that's like a re-ranking step, right? First step in first ranking, you use BM25, which is really fast, low memory usage, and then in the next step you will use dense passage retrieval. That way you can optimize them. uh, yeah, computing and informatics has the hands raised. We don't have the ability to unmute. If you can post your question in the chat, that
That
would be
is
good.
me. That is
Yeah.
me.
Go on. Do you
I
have
think
a
I think he I don't think he has a question. I think he doesn't have a question. I
Okay.
think that's what he's trying. He's just trying to say that it's him. It's him. So yeah.
And then we have one final, yeah, if any, like, if you want to add more to the question, go on. We have a couple of more
Mm,
questions.
no, I think we're good. So there's another
Yeah.
question in the chat.
Yeah, there are two more. What are the current cases where RAG does not work well? Things like negation, right? When the question is about, I mean, in general, similarity search doesn't work well for negations. When there is not and does not, like it doesn't understand those meanings. Uh, and as well as when in structured data side, right, like where tables, graphs, or multimodal use cases, RAG does not work well. uh, yeah, those are the main two cases where RAG doesn't work well. Yeah, if you have other thoughts, you can if any book, feel free to add it. How is RAG different from MCP? MCP is a different concept. It's MCP is used for your your LLMs to invoke tools, right? You can define a calculator tool. If the user asks a question about some calculation, you can connect your LLM with calculator tool with MCP servers, and that way your LLM say, hey, for this answering this question, I need to invoke calculator, and it can talk to calculator too. RAG is all about, okay, you have large amount of documents, and based on user query, you retrieve relevant documents and then use that to answer the question. So yeah, those are the questions.
Yeah. So I think yeah, I think we're good. Um,